and welcome to this presentation. My name is Craig Terrian. I'm a product manager here at SolidWorks.
And today joining me from CAMWorks is Mark Bissell. He's a senior application engineer. And along with Mark is Carl Ram, and he is a technology manager at CP-Carrillo in Irvine, California. Hi, guys.
How's it going?
Hi. Hi, Craig. Good. Well, you're online, which is good. And so Mark and Carl are joining us online on the GoToMeeting. So first, let me go through the agenda, what we'll be covering in the presentation. First, just a little bit about the CAD CAM Slam webinar series, some things on where to find partners on SolidWorks.com. Design the through manufacturing process, the integrated process versus the non-integrated process. CAMWorks Overview, a demo, a great customer story from Carl on how they're using both SolidWorks and CAMWorks in a totally automated environment. It's incredible. A little bit of a summary, and then some questions at the end. So we'll be holding our questions until the end of the broadcast. If you look at your GoToMeeting panel, if you open up where the arrow is on your GoToMeeting task pane, you'll see an area for questions. Right? If you click on the plus sign where the questions is, you can type in your questions there, and we'll answer them at the end of the presentation. Okay? So let's get into it. So first, why are we doing the CAD CAM Slam webinar series? Well, the first reason is to introduce not only SolidWorks users, but also people who use CAMWorks and anybody else who's interested in how our products work together. Basically, CAMWorks is a gold product CAM partner. They're certified gold, which means that they're fully integrated inside of SolidWorks. That basically means when you're working in SolidWorks, you can jump right into working in CAMWorks, and if you're working in CAMWorks, jump right back. And you're not opening up any new windows or anything like that. You're totally inside SolidWorks. What you will see is a great presentation on CAMWorks, how it works and how it's integrated into SolidWorks, as well as a demo, and also a great presentation from Carl Ram at CP-Carrillo. How to find partner information on our website. If you go to our main page, SolidWorks.com, if you go to the search area, you can type in the name of a product you're interested in or the name of a company for a partner product. Another way you can get there is if you go to the products area, you can go to partner products, and then you can search on company, product, and keywords. You can also sort by companies that are gold partners, meaning fully integrated, and companies that are certified or solution partners who work closely with SolidWorks, but they're not usually fully integrated. Okay, so we're talking a lot about integration, and specifically what we're focusing on in this presentation is integrated CAD and CAM, and how the SolidWorks Gold CAM partners really fill that spot for us where people are designing and they want to have their CAM system, they want it all in the same system. So CAMWorks is one of those CAM partners. So let's talk about the traditional, what we usually see out there, the non-integrated design through manufacturing process. And as an example, I'm going to use the mold design process, all right? So in mold design, I might start with an initial part design. Then maybe that might be in one CAD system. Then to go to my mold design system, I might have to export and import that geometry, repair it, bring it over, look for like draft issues, maybe fix some design issues. If I have control of that model, I might do some model updates to it. Then let's say, well, I use another system for my drawings. I'm going to export again from that system and then go to my drawings, all right? And then from there, I might take my part out again and go to a CAM system. So export out to a CAM system, bring it back in again. And you notice all along the way, I'm breaking the chain. I'm not in the same system here. I have several different CAD systems, different CAM systems, drawing packages. I've got a lot of different systems here. And what's happened is I've kind of broken my design and manufacturing chain. They're not fully connected because all of these red areas are areas where I have to stop, export, and import. So it's not a fully integrated system. And what really kills you is when a design change comes along, okay, you have to start the whole process all over again. And when you're talking about, even if it's just machining plates and things like that, you're always going to get design changes. And the more you can eliminate these red areas, these export and imports, these data translations, the better off you're going to be, because you'll be able to eliminate the barriers between all these different functions. Your data accuracy won't be in jeopardy, all right? Because you right now, when you're exporting and importing, the geometry can slightly change on. Also, you have to wait until somebody else is done with their job, typically when you have a non-integrated design through manufacturing process. You have to wait until the part design is done so you can do the NC toolpathing. Next, it's very time-consuming to export and import and repair the data. There was a study done a few years ago in the mold design area where people were saying it was about 70% of the time they were spending in design was exporting, importing, and repairing their data in between all these stages. So it can be very time-consuming. And finally, it's expensive to maintain and train people in all these different systems. So let's look at an alternative process, which is the integrated design through manufacturing process. And this is the one where you'll be seeing today with SolidWorks and CAMWorks being fully integrated. First, here are all my different stages of the process. I have my part design. I've got my mold design. I've got my drawings. I've even thrown in a structural analysis part, and I've got my CAM design. But if you notice, they all came up on the screen at the same time, and they're all integrated. So what that means is I can make a change to my part design, and all those changes will reflect through my molds, my electrodes, my drawings, right down to my CAM information. So I don't have to worry about waiting for somebody to get done with their job so I can re-import the model, and fix the model, and then start doing my job. So what this does for you, an integrated design through manufacturing process, like we're going to see today with SolidWorks and CAMWorks, is that data translations are eliminated. Design barriers are eliminated. Data accuracy is maintained. I don't have to worry about that I'm slightly tweaking the geometry every time I export and import. Concurrent design is promoted. I can be doing my NC toolpathing. At the same time, I'm still making changes to my part or to my mold tooling in this case. I have complete associativity. I never have to worry about the design change not propagating to all the other functions. So in other words, if I make a change to my part, my mold will update, and my NC toolpaths will update with my mold. And finally, it's ultimately cheaper to maintain and train people on one system, or in this case, two systems that have very similar UIs, as you'll see in the demonstration coming up. So now I'd like to introduce Mark Bissell with CAMWorks. He's a senior application engineer out of Arizona. Mark, you're there?
I am.
Great. Why don't you take us through the overview of CAMWorks and into the demo?
Terrific. Thanks, Craig. And thank you for all your listeners out there who are taking the time to watch this webinar. Geometric Technologies is the maker of CAMWorks. We're a division of Geometric Limited. We have over 3,500 employees worldwide. We have offices in the U.S., Europe, and Asia. And we've been involved in product development for Dassault and SolidWorks for many years. Can I have the next slide, Craig? We were originally partnered up with SolidWorks back in 1995. We became the first gold CAM partner in 1997, and we're the de facto CAM package for SolidWorks. We have more experience programming SolidWorks parts than anyone. Okay, Craig, could I have the next slide? As I mentioned, we were the first certified gold CAM partner, and CAMWorks creates toolpaths directly from the SolidWorks model. The toolpaths are generated completely within the SolidWorks environment, so you never have to leave SolidWorks to go into CAMWorks. They are fully integrated. And all the CAMWorks data is stored directly into the SolidWorks files. And CAMWorks works with both the part and assembly files as well. This minimizes the consuming time for rework, as Craig mentioned. We have several CAMWorks modules. We have 2.5 through 5-axis milling, machine simulation, volume mill, turning, mill turn, and wire EDM. We also have the Electrode Works product for the EDM sinkers. Next slide, please. And we were the first CAM system in SolidWorks to offer feature-based machining. Feature-based machining recognizes features automatically. We use AFR, or automatic feature recognition. Our AFR system is the best in the world. It'll recognize up to 20 different features, not just holes, but also slots, pockets, bosses, a number of different features. And this can speed up your programming time as compared to traditional CAM systems by up to 90%. We were also the first to introduce knowledge-based machining inside SolidWorks. And this knowledge-based machining captures the best practices of your best programmers and machinists and saves them to be reused so that the next time you run into a similar part or similar features on a part, it'll be machined automatically. And this improves the quality and consistency of the parts. And it also allows for full automation using the CAMWorks APIs. We also have true model associativity, so that the changes you make in SolidWorks will be updated automatically in CAMWorks. CAMWorks is easy to learn and easy to use. And we also have a command manager similar to SolidWorks. And the Solid Professor video lessons we also have for CAMWorks to help reduce the learning curve. Next slide. Could I have the next slide, please?
Yep. You have it now?
We do.
Okay.
and
there's a little delay on GoToMeeting right now, so.
No worries. And we also have high-speed machining and high-performance rough milling strategies to reduce your cycle times by as much as 80% and increase your tool life by as much as 500%. Okay, next slide. And finally, we have world-class training and support. We have offices in over 40 countries. We have more than 75 value-added resellers worldwide. And we have a certification program for our applications engineers similar to SolidWorks. Okay, could I have the next slide, Greg? So now it's time to see CAMWorks in action. And Craig, if you'll transfer over to me.
Sure.
Okay. So I'd like to begin by just talking about the integration between CAMWorks and SolidWorks. And you'll notice where we're in the SolidWorks environment right now. And you can see that we've added a couple of tabs to the standard SolidWorks environment. One of those is a feature tree for the CAMWorks machinable features. These are as opposed to the features that are used to develop the part in SolidWorks. And then we also have a CAMWorks operation tree, which is where our operations and toolpaths will be posted. So what I want to do is I want to begin by running automatic feature recognition on this part. And I mentioned earlier that the AFR in CAMWorks is the best in the world. In fact, it'll recognize 20 different features, over 20 features actually, and not just holes, but rectangular pockets and bosses and slots and so on.
Hey, Mark, and I want to mention something about that too. Is the difference? Remember, in SolidWorks we have things called features, and the features that we talk about in SolidWorks are design features. So you'd extrude, you'd create a fillet, but the features that Mark is talking about when you use automatic feature recognition, he looks at a part like this, And that pocket, which might be an extrude with some fillets on it, CAMWorks sees that as being a pocket feature. So the features that Mark is talking about are manufacturing features. So I just want to make sure that's clear, Mark, to everybody in the audience.
Sure. These are machinable features that we're going to extract automatically. So let me go ahead and run the automatic feature recognition. And CAMWorks will go through and analyze the part and look at all the machinable features of the part. In fact, machinable features are sort of the opposite of the model. These are features that we want to remove from the stock in order to leave the model in place or create the model. Okay, so all of our features have been added automatically to the CAMWorks feature tree. And now what I can do is I can go ahead and create the operations plans for these features. And as I run this, CAMWorks will use its knowledge-based machining to pick the best tools and processes for machining this part. And your own shop's tools, and I want to emphasize this, that your own best practices from your machinists and programmers can be stored inside the knowledge-based machining so that the part is machined exactly the way you want it to be machined when it's using this generate operations plan. Now what I'd like to do is go ahead and sort these operations. And the idea here is that what I want to do is I'd like to do all the milling before the center drilling and drilling. And so to do that, I want to sort these operations, and I have a sort operation function here. And it'll sort the operations that in the order that you see over in this list. And if I want to change that order, I simply drag and drop the feature, and it'll change the order. I can also save these sort schemes for use later on different parts. So in this case, I want to do all the milling first. I'll just hit apply. You'll see it automatically sorted all the operations, and it'll do all the roughing before the contouring, center drilling, and drilling. Okay. Now I want to generate toolpaths. There we go. And now the toolpaths have been generated to machine this part. Okay. And we can look at the result in toolpath simulation. So I'll go to the simulation, and I'll run the toolpath simulation. And we can see how the part is going to be machined. Terrific. Okay. What I can also do at this point to make sure that I haven't left any areas unmachined, I can use my model compare over here to show the difference between the SolidWorks model and the CAMWorks machined part. And you can see now that everything is in green here, and that means that the entire model has been machined correctly. Okay. Okay. Now I want to go ahead and generate G-code for this part. I'll give the file a name. And then go ahead and generate G-code for machining this particular part. You can see my post-processor or machine have been selected down here. I've defaulted those, and those defaults can be set up in the knowledge-based machine or TechDB. And now we can take a look at the G-code that is required to machine the part. Terrific. Okay, looks real good. Okay, and now we could send this file to the machine, and we could machine this part. Okay. Now, I want to emphasize here how quickly all that occurred, because through a traditional CAM system and without using AFR, or automatic feature recognition, you would have had to have created all these features manually. And that's true even about some CAM systems that reside inside SolidWorks. And that's a time-consuming process to create each of those operations. Okay. So now what I'd like to do is to talk for a minute about the CAMWorks associativity with SolidWorks. And we mentioned earlier about how you can make changes to the part and that the CAMWorks model will update automatically. And these changes can occur automatically as well for configurations. So I also want to point out that CAMWorks has configuration support for SolidWorks. So in this particular instance, what I'll do is I'll switch over to this new configuration. And this new part configuration, as you can see, has added quite a bit to this part. There's quite a few features. And when I go over to CAMWorks, you'll see right away it has noticed that there is another configuration, another SolidWorks configuration. And what it wants to do is to add that configuration to the CAMWorks configuration tree. We also have a configuration tree in CAMWorks similar to SolidWorks. And so configurations will be added automatically. And now the system is going through and it's looking at all the new features that have been added to the part. You can see a lot of holes and pockets that have been added. And what it'll do is it'll identify all these features and automatically recognize them and add them to my feature tree. And you can see they've all been added now. And now what I want to do is generate the operation plan for all of those new features. So I'll go ahead and hit the generate operation plan. And in this case, what I can do is just update the plan that I have so that these new operations will be added to the operations tree. Okay. Now I'll go ahead and generate toolpath for the new operations. And then I can go ahead and sort the operations as I did earlier so that all the milling will occur first before the drilling and spot drilling. Okay. There we go. Everything's complete now. Let's take a look at the simulation. And we can see the new toolpath and the new configuration as machined in CAMWorks. Looks really good. Okay. All right. So let's go ahead and generate some G-code now for the new configuration. And I'll give it a new name here, because I've used that one already. And let me overwrite that and go ahead and generate G-code for the new configuration. Okay. Terrific. And here's all the G-code now to machine the new model. Okay. And you can imagine now, especially if I look back at the operations tree, imagine having to create all of these operations using a conventional CAM system. This would take quite a while, maybe several hours even, to program this part. Okay. Okay. All right. So now let me switch over here, and what I'd like to show you now is something a little more complex. So let me bring this part up here. And in this case, what I've got is a part that represents a soap mold. And so this particular case, I've developed the soap in SolidWorks and then used some of the mold functions to automatically create the core and cavity, or in this case, 2 cavities. And what I'll do here is I want to focus in on just one particular component of the mold. So let me hide these other 2. And then let's take a look at this particular component right here. Okay. I'll go over to CAMWorks, and rather than use AFR this time, let's take a look at a little bit closer look at the mechanics of using CAMWorks. So in this case, what I'll do is I'll go in and insert a mill part setup. and choose the part. And you can see the arrow indicates the direction that the tool is going to be coming in at. See? And I'll select multi-surface machining. Go ahead and now we can see that a multi-surface feature has been added to the feature tree. And this feature is of the entire part. So I'll go ahead and generate the operation plan. And you can see that a couple operations have been added to the feature tree, operations tree, I'm sorry. And now let me insert a contain area, because what I'd like to do is restrict the machine just this particular area. Remember, I chose the whole part to build the feature. And so I'll go through and insert the contain areas on each of these operations. So that the machining occurs only in the cavity. Okay. This looks great. Now I'll go ahead and generate the toolpath. And while this is generating, I might point out that that this would be quite complex to machine conventionally. Even using a CAM system, it might take several operations, and there might be a lot of work involved. In this particular case, I've stored the strategy for machining cavities like these to my knowledge-based machining, my TechDB, and now the part will be machined automatically using the processes and best practices of my best programmers and machinists. Okay, so let's go ahead and take a look here at the simulation. And I could wait for this simulation to run. You can see it might take a little while there. So instead of having to wait for the entire thing to run, let me just go back and turn on turbo mode here. And what I can do is look at the final result of the machine pocket. Very good. Okay. Now I'd like to turn my attention to this particular roughing, the roughing here, this particular operation here. And what I'd like to do is talk about another feature that's inside CAMWorks called Volume Mill. And this is a new feature. And what Volume Mill can do is greatly reduce the programming time involved for machining this part. And if I go to statistics right here, I can look at the time that's required to machine this part or to rough it on this particular operation. And that's about 22.5 minutes. And you can see where this might take a little while to machine this cavity, and particularly if you had a multiple cavity mold, take even longer. So ideally, we'd like to reduce this roughing time. And in order to do that, we've added a new feature called Volume Mill. And so what I'll do is I'll go and select the new Volume Mill selection. And using Volume Mill, what occurs is that the toolpath Volume Mill will create will start at the bottom of the pocket. It'll take the full flute length of cutter into the pocket, and it uses customized toolpaths to generate the roughing passes required. And then what it'll do is it'll step back up from the bottom of the pocket, and at that point, it cuts out only the material that's left from the original roughing at the bottom of the pocket. So here, what I'll do is I'll go ahead and increase the surface footage for the roughing for Volume Mill. With Volume Mill, you can typically double or triple your surface footage. And so I'm going to increase it. Then I'll go ahead and go back to the Statistics tab. And before I do that, let's preview the new Volume Mill toolpath. And there, now our new volume mill toolpath has been generated. And let's go look at the statistics now and see what kind of time reduction we got. Look at that. It's down to 12 minutes from 22 and a half to 12 and a little more than a half. So we've reduced our machining time by more than 10 minutes just on this one roughing operation. And if we had a multiple cavity mold, this might save us a lot of time in machining. Okay. All right. This looks really good, and I could go ahead and post this as it is, but let's just move on, and let's talk about another new feature that's inside CAMWorks. And to do that, what I'll do is I'll switch my configuration here. And in this particular part file, I also have a configuration where we've added some lettering to the SOAP. So there's our lettering. And let me just hide the SOAP part here for a minute. And let's just focus on the cavity again. Okay. So here's our cavity with the lettering in it now. And what we'll do is, before we move on to Electrode Works, I'd like to talk about another geometric product, and that's called DFM. With every package of SolidWorks, there is a DFM Express version that's shipped with the product. Okay. DFM stands for Design for Manufacture, and what this tool will do is that it will look at all the features that are in my SolidWorks model, and it will determine if there are any features that are difficult, expensive, or even impossible to machine. I'll go ahead and run DFM here.
So again, like Mark said, DFM Express comes with every SolidWorks package, and there's actually an area in here where you can set up some options. So manufacturing practices, there are rules that it checks for, like for instance, the depth of the hole to the diameter of the hole. You know, the diameter size of the hole to the depth, or sharp corners, things like that. It looks for, and all those things can be set up, and you can set up your own manufacturing rules. You know, if I violate these rules, let me know where I'm violating these rules in my part.
That's exactly right, Craig. And in this case, what we find is that there's some sharp corners that have been added to the part, and inside sharp corners in particular, which are difficult to machine. So, and we can pick any of these instances and zoom in, and you can see the sharp corners have been added to this particular part. Okay. I might also mention that we have the settings that Craig mentioned, and we also have a pro version of DFM that is used widely by electronics and automotive firms, large firms, and this DFM Pro version can save a lot of time and money by catching errors in the design early in the design process and basically automating the design review process. And we have packages for the mill drills, for turning, for sheet metal, injection molding. So there's several DFM packages available. Okay. So these letters will be easiest put into the bottom of this cavity using Electrode Works, or using an electrode, an EDM sinker electrode. And so what we'd like to do now is take this file over into assembly and create an electrode using a new product called Electrode Works. Okay, so here's the cavity. And you'll notice where ElectrodeWorks is also fully integrated inside SolidWorks. So I have a tab here for ElectrodeWorks, for the ElectrodeWorks features. And if I just go and select to add an electrode, and it wants me to save the assembly first, and the documents involved. And what I can do is go ahead and then add an electrode using ElectrodeWorks automatically. Okay. And what I can do here is select from a library of electrode holders. And these libraries can be user configured and user created. And what I'll go ahead and do is select one of these electrode holders for my electrode. And then I'll go ahead and select the part that I want to burn. And then I'll pick a direction for the burn so that ElectrodeWorks knows which way I'm going to be coming into the part. Okay. And then what I want to do is go ahead and select the faces of the portion of the part that I want to burn. And this might seem a little tedious, but remember that when it comes to electrodes, there's oftentimes when you want to burn one face and not another. So this allows you to select the faces individually. And now that they're selected, let's back out a little bit here and say Calculate Electrode. And the electrode is automatically created by ElectrodeWorks and added to my SolidWorks assembly. This looks great. Okay. And this becomes the electrode becomes a part in the assembly or component in the assembly, and I can open up that part and look at and edit the electrode as well. I might mention at this point, too, that I could also add spark gap or clearances or so on, and it will automatically offset the geometry for me, for example, for the spark gap. Okay. And at this point, what I'd like to do is I'd like to take things to another level now. We've mentioned the APIs, the Applications Programmable Interface, or Applications Programming Interface. And what I'd like to do is to introduce Carl Ram. Carl, are you there?
Yes, I am.
Hi, Carl. How you doing?
Good. How you doing, Mark?
Good. Carl is with CP-Carrillo. And just switch over to a PowerPoint here. And let's talk about Carl's application of SolidWorks and CAMWorks at CP-Carrillo. And Carl's been a SolidWorks user since 1998 and a CAMWorks user since 2006. And he's done API development using both the SolidWorks and CAMWorks APIs since 2005. And Carl, why don't you tell us a little bit about CP-Carrillo?
Yeah, sure. First, I just want to say thanks for inviting me. Mark, Craig, nice to be here. And to the users out there, I'm an end user myself, so this isn't something that I typically do every day, that's for sure, as far as the demo here. But CP Pistons, I've been with the company about 6 years. I'm a technology manager here. It's actually CP-Carrillo now. We've acquired Carrillo Rod since, I believe it was 2010 or so. We design and manufacture pistons and connecting rods for the sport racing industries and high-performance vehicles. We supply high-technology components to numerous racing circuits, including NASCAR, NHRA, American Le Mans, World Rally Grand Am, AMA Supercross, FIM Speedway Grand Prix. We do everything from cars, motorcycles, to boat engines, and even airplanes. That's just a pretty quick rundown. We make high-performance connecting rods now in the same company. Since 2010, we physically moved under the same roof here. So that's pretty much just a brief description. And if you guys, Mark or Craig, or if you have any questions along the way, feel free to stop me.
Sure.
We've integrated automation here at CP-Carrillo completely from order to parts. So what would happen typically is that we'd take a technical sales order via telephone or even emails, and it goes into an automated system where SolidWorks captures that data automatically from our database, imports it into a SolidWorks model, generates the SolidWorks design, and then automatically incorporates CAMWorks, which is interfaced with SolidWorks, and pulls that data in and builds the CAMWorks model directly related to that SolidWorks model, all automatically. We have programmers on standby that will verify these individually. Once all this work has been done, automatically they will verify those, as you saw Mark doing through a verification at the end of CAMWorks. Those are automatically posted directly to the controllers out in the shop where they're machined. So an operator would literally scan the job in at the machine. That pre-posted CNC code will pop up into the controller, and he'll go through and machine that part, and on it goes into our quality inspection and ultimately to our shipping bench. Just a quick overview of the automated system that we've created virtually because of the integration between SolidWorks and CAMWorks using APIs, which I normally use Visual Basic to control the APIs. There's a couple different languages you can use. We use Visual Basic to grab the data from our network, which is an Access database, and import that data directly into the SolidWorks and go through this complete flow chart as you see here.
Great. Okay, Carl. I've got a short video, actually, that I'd like to show at this point of how Carl's automation works. So let me bring that up.
This is a pretty cool little example, just one little example of what actually happens when something is ordered and it goes through our data entry system. This is what would be used. This is a video of a debug program that we used to go through where a programmer would actually call up a macro up in SolidWorks toolbar here. And that'll basically just bring up a list of macros that's available to him. As you can see, this list of macros here. So he chooses a specific operation. In this case, it does the whole top of the piston and enters the job number for that. And it will automatically go and capture that data from that job and import it into SolidWorks, where we have a whole list of library features that are stored that can range from any application, whether it be big block Chevy, small block. As you can see here, something like a big block Chevy. I don't know if you can pause it right here or not. If you look at the, well, I guess we keep on going. What this does now is it's automatically taking those features from SolidWorks and importing them into CAMWorks.
Let me bring it back for you, Carl.
Oh, okay. That's fine.
There we go.
I just wanted to point out these very small holes at the very top of the piston. Those are like a 47 thousandths hole, very tiny drill bit goes in there. As you can see, some of those holes are on drastic angles and curves. that's not something you would normally want to just take a drill and try and drill. It'll snap that little drill in a second. But with the automatic feature recognition that CAMWorks has, it can recognize the topology of this piston that SolidWorks had created, and it can actually control the exact entry point of each one of those holes. So we can control with the special attributes that Mark was talking about. You can make custom attributes. In this case, we made an attribute that would do a spot instead of a drill. It uses a little end mill, and then it'll chase that with a little drill. So we can go on a curved area like that with a spot end mill, and it knows exactly where to start and how deep to go. We've made that customized attribute. So anytime it recognizes that there's a hole that's that small, it'll go through the automatic feature recognition. You can go ahead and launch this and maybe pause it at the other side. So we'll go ahead and let this run through, and CAMWorks now is pulling all those features from the SolidWorks feature tree, and it's updating the feature and operations tree in CAMWorks, literally compares them side to side, knows which ones to suppress and unsuppress. So we can make a full range of applications for pistons, from flat tops, two-stroke stuff, something like this with a big dome on it, special little holes. All this is done automatically on the fly per job as it processes through our order entry system. So you can see it ended up here. Is a nice place to pause it. Ends up here with the very last part or feature are those little holes that it puts in there. So I don't know that there's another piston company that's able to do this, especially automatically with a CNC machine, up until CAMWorks and the automatic feature recognition. This was done on a hand manually operated mill. And so the amount of time that those little holes took the process could have been anywhere from an hour to 2 hours, where this runs through the same machine with the CNC code automatically posted in just minutes. So this is just greatly increased productivity for us. And so, yeah, I guess you could go ahead and continue on with this and let it finish out in post. What happens at this point is it'll post this geometry to a number of different controllers out there. We have multiple machines that are capable of machining this particular operation. Like we have a 5-axis Cincinnati. We have also have a 4-axis Kitamura. It can post a job to either both or one or the other automatically. So there's no human intervention in this at all. It goes directly from order entry through this process, sits on a server, and processes this CAD and CAM both simultaneously. And we have error reporting, so if there's anything there, or say there was some sort of a data entry error or some sort of error, we have error reporting that will also notify that this did not post, and it goes into a queue where our programmers can manually take a look at each one of those individually. So it's a really good, this is awesome. I mean, looking at the volume mill and the kind of feature recognition that CAMWorks has, and the power in the APIs that both SolidWorks and CAMWorks have, has enabled us to integrate this system literally from order to parts. So you can see here, I mean, benefits are just tremendous. You can see the percentages of, from a fully automated using the API, we have improved consistencies, capturing, we're using the best practices. I love the idea that you can go make your own custom attribute. You know, if there's not a standard practice in there, you can create your own custom like we did with the little end mill as our pilot, and then the drill would follow behind that rather than using a standard, say, spot drill or something like that. We can rerun designs too. If there's any issue or somebody makes a design change, and let's say that whole, let's say one particular job, this job, let's say it was processed, and by the time it actually physically got to the machine, someone already made a design change. It's unbelievable that all we have to do is go right back in and rerun this job. The operator will look and say, hey, this has been changed, and he can literally be on standby. It takes just a couple of minutes, and then you can just shout. Well, we have instant messaging on our computers here. We send an instant message to the operator and say, in a couple of minutes, okay, it's ready to run, go ahead and run it. So the downtime is just really minimized on that. We've reduced our programming time. What used to take 10 or 20, even 30 minutes takes seconds now, literally. The same with the design time. The design time, sometimes the throughput was, maybe you had to wait 1 or 2 weeks, and now we have technical salespeople that can, on the fly, talk to a customer, create their piston, interrogate the model, give them sample weights. Through the APIs, we can give them projected dome volumes. We can change compression ratios, all on the fly during the middle of a, say, 5 or 10 minute conversation with a customer. We can shoot them images of what the part's going to look like. We've reduced our overall lead times. I would say we decreased overall lead times about 85%. We used to be a bottleneck in programming because it would take so long to go through a manual or a non-integrated, so to speak, operation. We've been able to greatly decrease the lead time, and we couldn't even keep up with production before. But now we're actually ahead of production and even producing more complicated parts with fewer mistakes than we did before. So it's nice as a programmer to be able to say that you're not a bottleneck anymore. The pressure is really back onto sales now and manufacturing to keep up. So that's been a big plus. The best practices in capture and reuse, and again, going back over, I just can't emphasize enough how nice it is to be able to customize your attributes for custom operations. And the trainability, we're able to cross-train now between Carrillo and CP pistons. We're able to cross-train. One guy can do rods one day, pistons another day. All these standard practices are all built in. So because everything's run automatic, if we were to, God forbid, lose one of our programmers, we would be able to bring another programmer in and train them basically these practices. Because things are so automated now, there's a very little training time. And I got to say also that the automatic feature recognition is a big plus for us here. I guess the only other thing would be the software support for SolidWorks and CAMWorks, and the API support that I've had has been just absolutely tremendous. SolidWorks has a unique way of recording APIs as you're creating them. So you could go through and manually create something while you're recording that, then go back in and edit that file. And it's like sort of like, I don't know if you're familiar with Office type APIs or Office type recording in Visual Basic. It'll actually remember every keystroke. You can go back and see exactly how that. So the learning curve for creating APIs isn't as mysterious as you would think. And along with the support that you get from both of these companies has just been a tremendous help for us. So if you have any questions, I'm happy to answer.
I think, with that, we've got about 5 minutes right now until the end of the webcast, and usually we can stick around and overrun by a few minutes anyway. I'd like to get right to the questions. Is that okay with you, Mark?
Sure, that's fine, Craig.
Okay, great. So let's see here. So if you have any questions, like I said before, please enter them into the questions area. in GoToMeeting. If you go to the side, you'll see questions. And I will start taking some questions now. So the first one up, Mark, this is for you. Can you slow down the simulated toolpath before you generate G-code?
Sure, absolutely. There's a slider on the simulation. I had it turned up. I know it probably happened quickly on your end, but yes, absolutely. You can slow down the path using the slider.
Okay. And we had a presentation. Yes, this webcast will be available. You'll be getting an email when it's available online, and you'll be able to review the whole webcast. With all including the questions at the end that we're having here now. The other thing is we'll have all the questions, and we'll be answering the questions too. We'll be trying to get back to everybody if we can on these questions. So if we don't, obviously we won't get to everybody. A lot of people online today, which is great, and we'll be getting back to everybody, with answers later on. Next question: how do you create the initial stock? As an example, previous simulation shows octagonal stock. What if we had round or rectangular stock?
That's right. Yeah, no problem. We have a stock manager, and you can create stock from an STL file or from an extruded sketch in SolidWorks. You can also just automatically get a bounding box around the part, and in assembly, you can also create stock from a SolidWorks part as well. So there's lots of ways to create stock, and they're all pretty easy to use and pretty automatic. So I understand the question. In my particular example, I had a sketch that I used for the plate, and I had used that as stock, and in that case, CAMWorks used that sketch automatically.
The next one is, and this is a great question, because here's a design for manufacturing type of question. As an engineering firm that sublets our manufacturing or goes outside for its manufacturing, it says this assumes that the vendor will be adding manufacturing features to the engineered SolidWorks part. How important is it for the initial engineered part to consider manufacturing process? So let me answer part of that. So this ties in with feature recognition. So one thing that we don't want to do is we don't want designers to be handcuffed into only using certain types of features. We want you as designers to be free to be able to design the way you want. The features that we're talking about, when CAMWorks comes in and looks at your part, it's looking at things like pockets and holes, and it's looking at the geometry in a hole, and it's saying, that thing down there looks like a pocket. Now, the way the engineer might have made that was it might have been an extrusion. You might have put fillets on the edges. You might have put fillets in the bottom of the pocket. But when CAMWorks looks at it using automatic feature recognition, it's going to see that kind of geometry as a pocket. Now, holes in SolidWorks just happen to be, if you use Hole Wizard holes, they just happen to be holes also in CAMWorks. So some features are similar between SolidWorks and CAMWorks, and some will be automatically recognized for manufacturing. So nobody will be adding features. We're really looking at the geometry that's there. Our CAMWorks is looking at the geometry that's on the model as designed in SolidWorks and interpreting that as a manufacturing type of feature. Now,
I should.
Yep.
Craig, let me add right there
Sure.
that the design features are on the SolidWorks feature tree, of course, and then the CAM features or machinable features are put separately onto the CAMWorks feature tree.
Can you pull up, do you still have CAMWorks up?
Sure.
And why don't you show that it's a separate tab, actually, it's kind of like the configurations tab, right? So there's,
right.
You have your feature tree. So show the SolidWorks feature tree.
Right.
Oh, sorry, okay.
I'm sorry. So here's the SolidWorks feature tree.
There's your SolidWorks feature tree, and in there you see you have bosses. There's a boss extrude there. You have all sorts of things. But when you look at the CAMWorks feature tree, which are manufacturing features, okay, it's going to look different. It's looking at, well, in this case, it's looking at this as a pocket machining or as a milling operation. So
that's right, a multi-surface feature here.
Yep.
And so, yep.
Go ahead.
Yeah, and you know what might be a better example too would be to go back to the plate that we looked at.
That's what I was thinking. The plate is a really good example. Yeah.
Right. So here's lots of features, machinable features. When we go to the feature tree itself, here's all the irregular pockets and the holes and so on that CAMWorks found, and that's on the CAMWorks feature tree, and that's separate from the SolidWorks feature tree, of course.
Right.
So design the part.
Engineers are designing the way, they have always designed. We don't have to change the way we're doing that. And then when it comes to CAMWorks, we're just recognizing those features. Now, a great crossover, though, is DFM Express, right, Mark? So
right.
a way to make sure that you're designing features as a designer, to make sure that you're designing features that are manufacturable, you should be looking at DFM Express, because that will tell you if you're making geometry that isn't manufacturable. So right here, Mark's bringing up DFM Express. Okay. Now, DFM Express is inside SolidWorks. It's in every version of SolidWorks. And there's also an advanced version of that Geometric also makes called DFM Pro. There's actually a link if you wanted to see more information about DFM Pro right there. And this allows you to put in certain restrictions about manufacturing. For instance, a typical one that I see is sharp corners on the inside, like on the inside of a pocket. You don't want to have a sharp corner because the tool, you can't have a tool with zero radius on it going in there. You'd have to use some kind of an electrode or something like that to go in. And on a part like this is a milled part, you wouldn't want to do that. So that's the type of things that it would pick up with DFM Express to make sure that your engineers are designing parts that are more manufacturable.
Yeah, and I want to add to that a little bit too, Craig, and say that the design for manufacture also identifies features that are difficult or expensive to machine. So, not only can it find features that are impossible to machine and might be not manufacturable at all, but also it can help you reduce the cost of your design by identifying features for you that are difficult to manufacture.
Yep. Let's see here. So we're on to the next one. Let's see. I'm not sure. Trial versions of CAMWorks, Mark, or how do you guys work that? I'm not sure.
You should contact your CAMWorks reseller if you're interested in CAMWorks.
Okay, and the way they contact their CAMWorks reseller is they go to CAMWorks.com or?
Right, www.camworks.com.
Okay. Let's see here.
I might also mention at this point, too, Craig, that there's a new CAMWorks Express package that's also available. Okay. So you'll want to contact your CAMWorks reseller.
Just like a lot of these are related to AFR, and I think we answered that question already,
sure.
To automatic feature recognition. So I'm looking at, says, how is the size of the SolidWorks file affected by the addition of the CAMWorks features and operations? 1.5, 2x, 3x, the initial size.
Yeah, it's actually not really near that. It's the actual sizes. I mean, obviously it depends on the number of operations and so on. But the operations are stored and the toolpaths are regenerated automatically. So all that information is not being dumped in the file. It is when it comes up, so the file sizes are not affected that dramatically by the CAMWorks data.
Okay. Next one, can automatic feature recognition be set up to make a second pass of finished pockets? And you have here, i.e. zero material removal pass.
Yeah, and what I want to emphasize about AFR, because I think there's misunderstanding in some ways about automatic feature recognition, and that is that, well, it has to be a pocket or a feature that's identical to the previous one, and that's simply not true. Automatic feature recognition in the knowledge database can be set up to recognize, for example, rectangular pockets of all different sizes, and different strategies can be assigned to those pockets depending on their size. So you can use larger tools to machine larger pockets and smaller tools to machine smaller pockets, and you can control your depth of cuts and your feeds and speeds and all that sort of thing, so that these operations will work precisely for a group of pockets, and the pockets can have just about any shape. Irregular pockets, it'll recognize, the AFR will recognize just about any shape of pocket automatically. And you know, one other thing I want to add too, Craig, is that, and this is regarding the API and Carl's automation. I think a lot of the listeners out there might be thinking that only applies to family of parts, and again, that simply isn't true. There are a lot of parts out there that have similar features, and even if you're doing similar operations, for example, you're a job shop, and every job that you see, every part you see is different. Well, you know, that's true, but also it's true that oftentimes in those shops that they're machining similar features over and over. They might be doing a lot of pocketing or a lot of roughing or a lot of drilling, that sort of thing. And any feature that you do more than once, even if it's of a different size, you can store inside the knowledge base in CAMWorks, and it'll be programmed automatically the next time it comes up. So it can be a big time saver.
Question on assemblies. So can CAMWorks operate on assemblies, for example, a part with fixturing, clampings, etc.?
Absolutely, and we also do machine simulation with full assemblies as well. So if you want to check your machine kinematics for collisions or interference, we can do that. We also have machine simulation as a module that's an add-on.
Okay. So I think we're just about out of time. I'm sorry, obviously we couldn't get to all the questions, but we're going to try to answer as many as we can and get back to people via email. As long as the information that we have in here is correct, emails and things like that, we'll be able to get back. Also, again, I emphasize we have this is going to be recorded. You'll get an email about when the recording is available. I'd really like to thank all of you for listening today. I appreciate we had a big audience today. That's great. I want to thank my friends from CAMWorks, Mark Bissell, and Sunil for being online today. And he was quiet today, but he was online. And really, thanks Carl Ram from CP-Carrillo. Carl, what an awesome demonstration and what a great implementation you guys have done. You've really taken what we've done in SolidWorks and what Geometric's done in CAMWorks, and you've taken it to a whole new level by running the APIs on it and really automating it. It's fantastic what you did. So I'd like to thank everybody for attending. Mark, any closing remarks?
Oh, I just want to thank everybody as well, Craig, and we certainly encourage you to go to www.camworks.com to find out more information.
That's it. Okay, everyone. We'll see you at our next webinar. I don't have an exact date on it right now, but you'll be seeing advertisement for it later on. Okay, thank you very much.